This is our basic circuit setup with our microprocessor controlled stepper motor. We have a parallax board with a basic stamp driving an MC3479P stepper motor controller. It's a 4-wire bipolar stepper motor. The lights on the bottom are indicating clockwise or counterclockwise, also full step and half step. And then on the top, when the frequency is slow enough, you can see the actual pulses that the control chip is creating to pulse the motor properly for operation. And there's also a 12-volt supply for the motor itself. The leads on the bottom are what's driving the oscilloscope, so you can see the frequency at which the stepper motor is switching between step to step. Here you can see the output frequencies changing from the microprocessor based upon the program control. Higher frequency means less time between steps. Lower frequency, more times between steps. Here you can see one section of the code that's actually on the basic stamp that controls the motion of the stepper motor. The for next loop, how long it is how long that motion is going to be created. The pulse out, that's the actual clock out, and then the time of that in milliseconds, I believe, and then the high and the low on pins 4 and 5 control either the direction clockwise or counterclockwise, and or full step or half step. So simply by varying those variables you can change direction, speed, and also length of turn for the stepper motor. Here's a schematic of the hardware version of the same circuit, with the microprocessor controls being replaced by the 2 switches on the side for full step and half step, clockwise and counterclockwise, as well as the 555 timer circuit on the top for creating the clock to control the length of time between steps. Here's a hardware version of the same stepper motor controller, same motor controller circuit, but now we use manual switches to change directions and change full step to half step. In order to change the rate of the clock, we'd have to change the frequency of the timer circuit over here. We did add one functionality where it has a photoresistor control on the clock circuit, but besides that you'd have to change this capacitor right here in order to change the rate. Here's the same stepper motor control circuit running at a much slower rate after changing the timing capacitor. Still the capability to change directions, full step, half step, but now at a much slower rate where you can actually see the pulses that are controlling the different poles on the motor.